In this video, we will answer some of our more advanced and interesting questions about robot performance. The visualizations we will create in this video are the most performance-boosting graphs we will make in this series. Knowing where our opponents shoot from is a valuable tool to play a more effective defense against them. If several robots on the opposing team have overlapping shooting locations, then those spots may be ideal locations to play efficient defense. Conversely, this type of visualization could be used by our team to better coordinate autonomous starting positions or to pick alliance partners that do not interfere with each other. This type of visualization is usually called a heat map. The first step towards making this visualization is to upload the background image. The one used in this example was made using Adobe Illustrator, but anything from Microsoft Paint to screenshots of the rulebook could work. What makes this image special is that it has grid lines. Grid lines are not necessary, but it helps your scouts more accurately designate robot shooting location. Just make sure the picture has enough landmarks such as field features or protected areas so anyone quickly looking at the page can see where they shoot from. On this image, the goals that the robots were shooting for are on the top of the image. It is useful to have the goals always on the same side, so shooting location will be relative, regardless of which side of the field they are on. After creating a background image, the next step is to import it into Tableau. To do this, go to Map, Background Images, and select our data source. Then, add the image. This image is a 4x8 grid. Therefore, we can set the range for the X and Y fields accordingly. Because in Access we already separated shooting locations into X and Y fields, all of our hard work is already done for us. To view the heat map, drag X and Y to their respective axes. Then, change both of them to dimensions. Each of these circles is a location that our robot has shot from. Currently, there is a lot of data on this graph. Let's filter team number so we can see what this graph looks like when we use it right before a match. Because Tableau can filter so quickly, it's not hard to generate a heat map like this for every single match. These heat maps can give our drive team a strategic advantage. After we filter down our teams, the image zooms in to the part of the field where they all shoot from. If we don't want this to happen, we can manually edit the axes so it doesn't resize. To do this, right-click on the axes. Then, change the range to fix and go a little bit before and after the range. Do this again with the y-axis. Now, the entire field is shown. If we don't want to see the zoom controls, right-click and hide them. Now let's find out which teams are shooting from which location. A good way to do this is to drag team number to shapes. We don't want to drag team number to label because if multiple teams shoot from the same location, only one of them shows up. Let's also make size a little bit bigger so it's easy to see overlapping teams. By defending this location, we would be defending against two teams at once. If we want to see how many points each team makes from that location, we can drag telescore to color. Whenever we want more contrast on a graph, we can always change the color palette to a diverging palette. On this graph, I like to reverse the palette because then the higher scoring robots stand out more. If we want to see how many times a robot has shot from that location, we can drag number of records to size. After creating this graph, we now can get some strategy out of it. For instance, Team 5333 makes a lot of points. However, they have to get past this easily defendable zone to get into their protected shooting area. A good opening strategy might be to try to stop them from getting there. If they get past us, we could defend this location to annoy both of those teams at the same time. We can also graph autonomous starting location. Unfortunately, for our starting location, we did not separate it into X and Y fields when we created it. Instead, we have a bunch of words that can't be graphed easily. Thankfully, we can create a calculated field to turn these words into coordinates. Let's create a calculated field for the autonomous X coordinate. This calculated field will be using a function. Functions can be added just like fields by double-clicking, or they can be typed in. Most functions, like average, for example, do their calculations on whatever is surrounded by the parentheses. Functions like case and if instead are written like a normal sentence and are terminated by the word end. Double-click the function case or write it in to start the function. Looking down at the tooltip, we can see that after case goes the field that we would like to evaluate, in this case, starting location. After starting location, we now give it a series of tests. When starting location is equal to front, left, then the X coordinate shall be 1. The format for a case function goes case field when this field is equal to this value, then give this value. Let's add another when statement. When starting location is equal to left, then X coordinate equals 1. Let me paste in the rest of this function. Notice that there is a when statement for every single possible outcome of starting location. When I'm done with everything, the word end is there. Let me quickly make another calculated field for autonomous Y. Notice that Y follows the same format, but instead gives us Y coordinates. When these coordinates come together, the autonomous X and the autonomous Y will graph our starting locations around this pyramid. Now, let's upload another background image. Because the image is still a 4x8 grid, we can keep the X and Y ranges the same. Now we can set the X and Y fields to the calculations we just finished. Now let's repeat the same process we used to create the tele heat map, but with our autonomous measures. Now we can see all of the autonomous starting locations. Let's pretend that instead of being against these three teams, that these three teams were our alliance. Now we can start to answer a complicated problem. Where should our alliance place the bots to get the most points? Well, following the same method as before, let's drag team member onto shape. And let's increase size. There appears to be 3 teams shooting from the same location. Which team makes the most points from there? To find this out, just like before, we can drag autonomous score onto color and change the palette into a diverging color scheme. it appears that Team 5333 makes the most points from that location. Also, let's drag number of records to size to see how many times they've pulled that off. It appears that they've been very consistent with making that many points. From this graph, it appears that our lines should set up along the back of the pyramid. Graphs like this save a lot of time when setting up before a match. Going back to teleop, there's another type of heat map that's also very useful for us. To save time, we can duplicate the sheet instead of building it up from scratch again. Let's make this a heat map of accuracy. In order to create a heat map of accuracy, we need to change the marks into pie charts. The quickest way to get the angles we want is to remove both of these fields from the shells and then to click on the teleop measures. By teleop measures, I mean the tele 1, 2, 3, 5, and missed shots. This doesn't seem very important, but if we go to colors, we can edit them. Now, let's make all of the hits blue and all of the misses red. This is a very fast and simple way to get accuracy. With accuracy, we can learn a few things. By comparing the two places that Team 5333 shoots from, we see that they are less accurate when they are closer. Using that knowledge, we could pick a strategy that might bait them forward, thereby lowering their accuracy. I have a few last tips for us. When graphing shooting location, we are not limited to only integers on the grid. We could have easily used decimals or even a much smaller grid. The only problem with doing that is that as the grid gets more precise, we can do less aggregation. Tableau can't find the average of several nearby points. They have to be on the same coordinate. But by putting shooting location into our defensive strategies, we can take our gameplay to the next level. Combined with graphs like distribution, these location graphs are some of the most defensively powerful visualizations a team can use to improve their strategy. Thank you.